So hello everyone. Today we are going to learn another interprocess communication mechanism, IPC technique called FIFO. Okay, as the name FIFO suggests, means first in first out. Data that will travel through the IPC mechanism FIFO will follow first in first out pattern. Now we have earlier learned about pipes. We know that pipe is a half duplex one-way communication channel. When we create a pipe, you get a buffer of size 64 KB. On one end of the pipe you will have the write file descriptor, and on the other end of the pipe you will have the read file descriptor. The FIFO, or the named pipes, when we create the FIFO, which are called named pipe also because they are identical to pipes, with the difference that it has a name associated with it. Remember, the pipes had no names associated with it, so FIFO will have a name associated with it, but it will not have any file descriptors unlike pipe. So it has name but no file descriptors. Because it has a name, therefore it is visible in file system also. We will be able to see it in a folder, in a directory in file system. Okay. So special kind of pipe. Named pipes, or the FIFOs, could be implemented among two distinct processes which have no common ancestral property. Now the pipes had a very serious restriction that pipes could be implemented only among those processes that had some common ancestor, and that the two processes had to share the file descriptor before the communication could begin. But in FIFO that restriction goes away. You don't need to have some kind of relation between the processes that want to communicate, and you don't have to share the file descriptors. Okay. Now this is how it works. Use an access point. Two unrelated processes opens a file to communicate. Whenever you have a file system, inside the file system you will have your named pipe implemented, that is a FIFO implemented. Okay. For the file system, FIFO will be just like some file, it will look like a file. You will have two processes connected to the FIFO through the file system. One process will open the FIFO in write-only mode and create the write file descriptor for it. Another process will open the FIFO in read-only mode and get the read file descriptor. So both the processes will be connected to the FIFO in a write mode using the write file descriptor and read mode using the read file descriptor, and use the ordinary write and read calls to do I/O through the named pipe FIFO. Okay. Some important properties. The FIFO or the named pipe are system persistent objects. When I say system persistent object, means they exist beyond the life of the process. They exist beyond the life of the process. That means beyond the life of the process means, suppose if a process comes in and creates a FIFO, uses FIFO. There are two processes that are connected to the FIFO. One process connected to the FIFO in write mode and another process connected to the FIFO in the read mode, and both the processes are able to communicate with each other. Then both the processes close the FIFO and go away. When both the processes are gone away, still the created FIFO will continue to exist and will be visible in the file system. Unlike pipes, where the moment the process used to get over, the pipe used to get destroyed automatically. Here the FIFOs will not get destroyed automatically. So FIFOs are system persistent objects. Therefore, FIFOs will continue to exist beyond the life of the process. They exist beyond the life of the process. Named pipes must be explicitly deleted by one of the processes by calling unlink system call. We have to use unlink system call. We can use RM call also to remove. But when you use RM call to remove, then what happens is RM will remove the file name. Your FIFO name, FIFO has a name. That FIFO name will be a file name. So the FIFO name or the file name will be removed. But that FIFO name or the file name is also connected with the 64 KB buffer in RAM. That 64 KB buffer in RAM will not be destroyed using the RM command. Okay, so rm command should not be used. Unlink call should be used. When you use unlink, then it will do all the things that the rm will do, that is remove the entry from the file system. And after removing the entry from the file system, it will also, before removing the file entry from the file system, it will also delete that 64 KB buffer. So the 64 KB buffer in RAM will be deleted, and the file names entry will also be deleted. So bottom line is that FIFOs are system persistent object. That means they continue beyond the process. They'll continue to exist in the process in the file system forever. If you have to delete the FIFO and you don't need any further, then you use unlink system call and give the FIFO name. Your FIFO will be deleted. Okay. So by default it supports blocking read and write. This I will take up later. First let us learn how to create FIFO. There are two ways of creating FIFO. One is using mknode command, another using mkfifo command. We will be using mkfifo now. Mknode also will use, but later. Now our system, the computing machine that we use, is the system is divided into the memory used in our system is divided into user space memory and kernel space memory. In the user space memory, we run applications, and in the kernel space memory we use the kernel threads, drivers, and all these things. The kernel runs. So the system memory, the memory in fact, is divided into user space and kernel space. In user space you run applications. And libraries. In kernel space you run drivers, the kernel itself, OS, you run drivers and other loadable kernel modules that we'll see later. Now the FIFO could be implemented. Suppose there is an application and there is an application here, and there is some loadable kernel module here and loadable kernel module here. Now if you have to establish some kind of communication between application to application, then you can implement a FIFO between the applications. Or if you have to establish communication between the application and the kernel module, then you can implement a FIFO which goes from user space to kernel space. Okay. This kind of FIFO, which is implemented between application to application and works in user space, is created using mkFIFO. And this kind of FIFO that is implemented between application running in user space and some kernel module, this kind of FIFO is created using mknode. Okay. As of today we will do this. Later when we do device drivers, we'll do this. Because this part we would have implemented ourselves in device drivers. Today we'll do this. So we'll learn mkFIFO and create the FIFO name. Once a FIFO is created, any process can access it, use it, and the FIFO will be visible in the file system. Oh, there's the diagram. So the name FIFO could be created between two applications running in user space, or it could be implemented between the process application running in the user space and some routine running in the kernel space. This is created using mknode and this is created using mkFIFO. We'll be using mkFIFO version. mkFIFO. Okay. So mkFIFO is a call that is used to create a FIFO. I told you when the FIFO or the named pipe is created, we have to give it a name. So this is the name we give it to the FIFO. And these are the permissions. Okay. When the FIFO is created successfully, it returns 0, and the created FIFO will be visible in the file system with this name, MKFIFO. To know more about MKFIFO, you will be using info MKFIFO. Info. You can use info MKFIFO. It gives you about information about FIFO. Okay. So it is declared in systat.h. Let me show you in the info pages. Info MKFIFO. FIFO special files. MKFIFO. You give the file name, which will be your FIFO name, and the mode, that is the permissions. You can give a brief reading to this abstract over here. Okay. So to know more about this, what we have to do is we have to implement the FIFO. Let's implement. Just have a look at this simple program. Here it is. We use MKFIFO. Now don't get bothered about the header files we are using. So that is not required here. We need only systat and systypes.h. Let us remove the other header files unnecessarily kept here. Okay. So we need these header files. MKFIFO is the call that we use to create the FIFO, and the name of the FIFO I have given is FIFO name. FIFO name is a macro here. Has defined FIFO name. Dot means in the current directory. Even if I don't give dot/path, still it will create in the current directory only. So in the current directory, I'm going to create a FIFO called myFIFO, and the permissions I have given here 0666 means 666. Read write permission for the other, read write permission for the group, and read write permission for owner. 0 means it's going to take care of character IO. So this is the FIFO name called myFIFO, and the FIFO will be created and return -1 for error or 0 for success. And if it is not -1, it will definitely successful. When the FIFO is created, you will say process ID created FIFO, and you will see that the myFIFO will be a FIFO present and visible in the file system. Let us do this. So it is already there, myFIFO, I saw that. Let's remove, unlink myFIFO. It was created by some previous activity. Okay. So let us run this program, and GCC 01 compiled. Okay. Get PID. We have removed get PID, and get PID we have removed UNISTD.h. UNISTD.h needed for get PID. Compiled successfully now, and now run. There you see process ID created FIFO. We reached here. Process ID created FIFO. What is the name of the FIFO we created? myFIFO ls. There you see myFIFO. I just removed it. It is created. Long listing. Do long listing. myFIFO is created on 11th May. At this time, look at the leftmost column here. P. It shows P. P means pipe. So it has a name, and it's a pipe. It's a named pipe. Okay. So that is how FIFOs are created. If you have any doubt, you can ask me now. My FIFO does not have any content. As you see, 0. Size of this my FIFO is 0. Okay. So this was just a basic introduction to FIFO. Let us have a look at another example. Again, I am going to create a FIFO. The name of the FIFO is same name. Now, if the FIFO with the same name is already present, it will give -1, and which will be interpreted as error. Okay. And because it will be interpreted as error, you have to exit the program and you will go. But actually it was not error. The FIFO you wanted to create, that FIFO was already created. It is a scenario, it is not an error. Okay. So what we need to do is we need to understand that the FIFO is already present and there is no error in creation of FIFO. So I introduce you to a call called access. Access is a system call which will check this file name if it is present or not. The file name I have given is my FIFO. It is present or not. If it is present, then f_OK flag will be set and it will return -1. I repeat, access will check whether this file name is present or not. If this file name is present, then f_OK flag, it's a flag, the flag will be set and it will return -1. Okay. So in this case, it will see that f_FIFO name is present, so f_OK flag will be set and -1 will be returned. Sorry. If the FIFO name is present, correction, sorry, this is a correction. If the FIFO name is present, then it will set the flag and return 0. Set the flag and return 0. Okay. If it is not present, then it will reset the flag and present and return -1. So in my case, FIFO name is present, so it will set the flag and return 0. Because it will return 0, my condition will become false. Because my condition will become false, therefore this block will not execute, in which you are creating FIFO. There is no need to create FIFO. The FIFO is already created. So you will come here and you will say FIFO is already created. No need to recreate the FIFO. Okay. So I will execute this program twice. First I will execute it, it will show you FIFO already created. Then I will unlink the FIFO and remove it. Then again I will execute it. You will see that it will say process created FIFO. Okay. I hope you understand the program and the scenario. Yes, Deepak. It's a flag. Flag is a status indicator. Can you repeat that, please? f_OK could not be printed by you from the application layer because this is one of the flags which are visible in the kernel. We will be able to use, manipulate and change this flag when we will go to the kernel mode in device Java development. We will do that. GCC compiled successfully and executed. When I executed it, it says my FIFO already created because we created in our last example, and there it is visible. Let us unlink it now. Gone. Long listing. Now it's gone. Now I run this program again. It says FIFO created, isn't it? So this is how you will keep control about how to create a FIFO, when to create a FIFO, when not to create a FIFO, when to report error, when to report presence of FIFO. So I introduce you to a call called mkFIFO, and then I introduce you to a call called access. Okay. For prototypes of these two calls, you can go to the appropriate header files and get the prototype as well. Like you go inside sysstat.h, user include, there you go inside sys and open stat.h. Here you will find mkfifo. There it is, mkfifo. Now, few things I would like to put light to here. mkfifo, about mkfifo. Used to creates named pipe. Or FIFO. Okay. This one, string constant. Name of FIFO. Then this is FIFO mode. Or user permissions. This is almost always given 666. Okay. Now the return type. The return type is extern int. Return 0 for success, or -1 for failure. Now, why it is external? Because the exit code is needed by other routines to determine if FIFO is created successfully and could be used for IO. ओके, क्योंकि इसका एग्जिट कोड सारे रूटीन्स को चाहिए होता है. FIFO बन गई बन गई तो हम उस पर काम शुरू करें। इसके अलावा ये the process of creating FIFO may throw exceptions. For which we have to write handlers. This we'll learn later. ठीक है? So non-null is also one of the parameters that I use with the exception handler also only, and this is also non-null also we'll see when we'll work with the handlers. So this is the MK FIFO. It works like that. Let us have a look at another example. Okay. Open. Now, once the FIFO is created, if you remember, I told you the FIFO has a name. You also remember I told you that the FIFO have no file descriptors associated with it. Because FIFO has a name, it is visible in the file system. Now, if something is visible in the file system, and that thing has to be accessed, then obviously you have learned in file IO that a process in the user space have to connect with that entity in the file system. Then it needs to create a stream between them, and the stream is created using the OPE and open system call. So MK FIFO will create the FIFO, and to start working with the FIFO, we have to open the FIFO. So one process will be able to see that the FIFO is created in the file system. Then that process will give the open system call to open the FIFO in maybe a write mode, and process will try to open the FIFO. So let's try to open the FIFO. Here we are. This is similar, the program similar to the earlier program. We had access to check whether the FIFO is already present. Then don't create it, otherwise create it using MK FIFO. If it is already created, don't create it, just say that FIFO already created, and you also give the process ID. And you also give the FIFO name. And then after that we are going to print. Listen, see this carefully. We are going to print going to open FIFO for writing. That we are going to open FIFO and get the file descriptor for writing. And in the very next call, we give the open call to open the FIFO in O_WR only mode. And the moment before the FIFO, because the FIFO is created successfully, it will be present in the file system and it will be opened successfully in the write mode, and you will get the file descriptor. And if in case you don't get the file descriptor, you will get error. You will print error, exit the program. But if the file descriptor is created, it will be the lowest available file descriptor number, which is 3. And you will come here and you'll say that the FIFO is opened successfully for writing and file descriptor is 3. Okay. So I hope you are able to understand this program. Please tell me Y or N or question mark or exclamation mark in the chat. Y for yes और N for no. नहीं समझ में आया. Question mark अगर कुछ question. हाँ दीपक, you have a question, please ask me your question. This property, not tendency. The write file descriptor that we have created is created and the file is opened in the write mode. So therefore this file descriptor will be used only and only to write into the FIFO. Let's execute this program. Compile and execute. (03) open and write. Enter. Compiled. So I have 03 open and write. Yes. Special file. Ordinary files are files that are resident in the secondary storage. This is a special file. It is visible in the file system, but is not resident on the secondary storage. It is resident in the RAM memory itself. Yeah, RAM is a volatile space, so it would be destroyed. For example, yeah, same. Only read only, WR only, and RD only could be used with FIFO. So I have just now created a program called 03 open write. I run it. When I run it, see the output. It says FIFO already created, because using as access it checked that the FIFO was already created. So it came to the else part and it says that FIFO already created. Then after that it goes to going to open FIFO for writing. It comes here, prints going to open FIFO for writing. Then it gave the open call. Now this is very strange. When it gave the open call, then either the open call will be successful or open call will be failure. If the open call will be failure, it will print the error message. If the open call will be successful, it will print this message. But in our case, it is printing none of these two messages. Now this is strange. This is the explanation for that. It is called block on open. Our process did not give any error, did not open the FIFO either, but it got blocked on open. Just like yesterday. Assume that there is somebody sitting in a meeting room and two people had to do meeting. One person have arrived in the meeting room for meeting. Will that person speak alone? Okay, it's 9 o'clock is time for meeting, so I'll start my meeting. Other person have not yet come. I'm alone in the room right now, but alone I start meeting. That is not possible. That is illogical. Similarly, the writer process is trying to open a FIFO for writing. What will it return? The writer process is trying to open FIFO for writing using the open system call. The question here is, what is the need to open the FIFO for writing in write only mode unless there is some reader present? Because this FIFO is not an ordinary file mapped to secondary storage where you can write into the file and store some data into the file, and data will be persistently stored in the secondary storage, non-volatile memory storage files. Instead, this is a special file. It is not used for storage. It is used for as a stream to transfer data from one process to another process. So no storage allowed. So therefore, there is no point in putting some data inside this FIFO. There is no point in writing some data into this FIFO unless there is a reader present at the other end. So the process trying to open the FIFO for the writing blocks on open. Block. You notice our process is blocked on open. We just gave this statement going to open FIFO. Then after that we didn't get error, we didn't get success also. So because the program is blocked on open for write. It is blocked because there is no process trying to open FIFO for reading at the other end. What is the point in opening a FIFO for writing when there is no process opening the FIFO for reading, and the FIFO could not be used for data storage? It is used for data transfer. You are making a phone call to someone. What is the point in, you have dialed the number, but the other person is maybe sleeping, not picking up the call, but still you are speaking because I have dialed, I am supposed to speak whether you listen it or not. That doesn't happen. Similarly, the no process will be able to open the FIFO for writing until unless there is some other process tries to open the FIFO for reading. Until unless that happens, the process that tries to open the FIFO for writing will go on block on open. This blocked state of the writer trying to open FIFO for writing is called block on open for write. The writer will be able to open FIFO for writing only when at the other end of the FIFO there will be another process trying to open FIFO for reading. Then the communication channel will complete. We'll do that here. Our writer process is block on open for write. Okay. Now we will see another program here. Another program which again use the same access for the same FIFO in the same directory, and this will try to going to open FIFO for read. FIFO mode is read only. Okay, and when it will be able to read, it will say for open FIFO for reading. File descriptor number will also be printed. So this is the program which we will compiled. We will run this. This process is already executing, and this process is in the going to open FIFO for writing, and this process in the block state. And then in another terminal I will run another program. Yeah, this another program will try to open the FIFO in read mode. Enter. Oh, see, opened FIFO for writing FDS3 writer process, opened FIFO for reading FDS3 reader process. Now both the processes are able to open the FIFO for writing. This side open is successful because another process tried to open the FIFO for reading. So both the processes will be able to open at the same time. It has the lowest available file descriptor 012 was created, lowest available was 3, and this process also had the 012 used, lowest available was 3. So both the process gave the file descriptor number as 3, but this is 3 for writing in one process and this is 3 for writing in another process. Now the FIFO has been opened from both sides for writing and reading. On one side you can use write call, write. On the other side you can read using the read call, just like ordinary file IO. So you noticed that the writer process and the reader process are not having some kind of relation, ancestral relation, that you had to create another process using fork and exec. Both the processes executed independently, and after the execution was over, both the processes are gone now. Both the processes are over and gone, but your FIFO is still present because it is system persistent FIFO. It will continue to exist until unless you remove it using unlink call. Okay, so this was the basic introduction to FIFO, and please continue the discussion in the next class.